Today's lesson is on power series and how we can arrive at new series through different types of manipulation. So let's start with the Taylor polynomial for e to the x. E to the x is going to equal 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial. Okay, we can arrive at these others by a simple replacement. We can replace negative x in for all of the x's. And then we will simplify. So this is going to go to 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial plus x to the fourth over 4 factorial. And we're just doing the fourth degree, so that's why I'm just stopping at those points. Okay, let's do the same thing with 2x. So 1 plus 2x plus 2x squared and then simplify. So 1 plus 2x plus 4x squared over 2 factorial plus 8x cubed over 3 factorial plus 16x to the fourth over 4 factorial. Okay, negative 3x. Okay, so this is going to be 1 minus 3x plus 9x squared over 2 factorial minus a 27x cubed over 3 factorial plus an 81x to the fourth over 4 factorial. For the last one here, we're going to replace x squared. X squared over 2 factorial, x squared cubed over 3 factorial, x squared to the fourth over 4 factorial. So 1 plus x squared plus x to the fourth over 2 factorial plus x to the sixth over 3 factorial plus x to the eighth over 4 factorial. So now we can do this in general. So the sigma notation for the series for e to the x is x to the n over n factorial. So e to the ax is going to be ax to the n over n factorial. So we're going to use that fact to write the function represented by these power series. So here we're just looking for what's in the parentheses here. Here it's the negative x. So this is going to be e to the negative x. This I can rewrite as 2x to the n. So this will be e to the 2x. Can rewrite this one as negative 3x to the n. So this function is e to the negative 3x. This one I can rewrite as x squared to the n, which means this is going to be e to the x squared. This one I can rewrite as x over 3 to the n over n factorial, which means this is e to the x over 3. Okay, for this next section, we can write out the series and then see what's happening here. So when n is 0, I'm going to get 1. When n is 1, we get 2x, and we get a 4x squared, and so on. So this is an infinite geometric with an a1 of 1 and a common ratio of 2x. So I can write the function as 1 over 1 minus 2x. Here, when I plug in 0, we're going to get 1 again. Then we'll have a minus 3x. Then we'll have a plus 9x squared. So this is going to be 1 over 1. My common ratio is negative 3x, so this will be plus 3x in the denominator. This is going to be 1 plus x cubed plus x to the 6th, and so on. So this one's common ratio is x cubed. So we have 1 over 1 minus x cubed. Here, our a1 is going to be 3 this time. Then when I plug in a 1, we're going to have a negative 3x squared. When I plug in a 2, we're going to have a 3x to the 4. So my a1 is 3, and my common ratio is negative x squared. So this is going to be 3 over 1 plus x squared. Okay, so let's just look at x to the n. So this is the series 1 plus x squared, and so on, which is 1 over 1 minus x. We're going to see this series a lot. Okay. If I were to take the derivative of 1 over 1 minus x, it would be the natural log absolute value 1 minus x times a negative 1, because we use the chain rule. Okay, and that's what we're going to use to find a series for natural log of 1 minus x. So ln of 1 minus x is going to be the negative, the opposite of the integral from 1. Okay. Since the derivative is this, the integral would be the opposite of this. So this is going to be negative the integral of 1 plus x squared plus x cubed. Okay, on up to x to the n. So then we'll integrate. So x plus x squared over 2 plus x cubed over 3 plus x to the 4 over 4 plus, generically, that's going to be x to the n plus 1 over n plus 1. And then distribute the negatives. So negative x minus x squared over 2 minus x cubed over 3 minus x to the 4th over 4. So I can write this as the opposite, 0 to infinity of x to the n plus 1 over n plus 1. Okay, so we're going to write the series for these different functions. So these first 3 are all infinite geometric, and that's always going to be a1 times the common ratio to the n. So here, this is going to be the series starting at 0 to infinity of 1 times 3x to the n. Here, we're going to have 2 times a negative 3x to the n. This one is going to be x squared to the n. Okay, this is going to be e to the 2x. So I'm going to put 3, and you can put that on the inside or the outside. Okay, so e to the x is x to the n over n factorial, so e to the 2x is 2x to the n over n factorial. Okay, this next one, we know from up here that the natural log of 1 over x is going to be this. So we're going to replace the x with a negative, or with an x cubed. So this is going to be negative 0 to infinity of x cubed to the n plus 1 over n plus 1. Here, I can rewrite this as natural log 1 minus x to the 1/2, and then use the log rule for powers to bring that out front. So then I can write this one as negative 1/2, try this again, negative 1/2 times x to the n plus 1 over n plus 1. Okay, another geometric one. So this is going to be 2 times x cubed to the n. Here this is sort of in the right format, but we must have a 1 minus something here. So to get that, I'm going to factor out the 2. That'll leave me with 1 minus x over 2. So this is going to be 1/2 over 1 minus x over 2. And then we could write it in sigma notation. So my a1 is going to be 1/2. My common ratio is x over 2 to the n. All right, so we're going to write the first 4 non-zero terms of the Maclaurin series of these by making a substitution. Okay, so cosine is our evens. So we have 1 minus 2x squared over 2 factorial plus 2x to the 4th over 4 factorial minus 2x to the 6th over 6 factorial. The general term is negative 1 to the n, 2x to the 2n, all over 2n factorial. All right, with something like this one, I'm going to start with my base, cosine. So cosine of x is equal to 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial, 6 factorial, and we're actually going to go one more. Okay, then I'm going to subtract 1. So cosine of x minus 1, we'll subtract that 1. So we have negative x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus x to the 8th over 8 factorial. And last, we're going to divide everything by x. So cosine of x minus 1 over x is negative x over 2 factorial plus x cubed over 4 factorial minus x to the 5th over 6 factorial, x to the 7th over 8 factorial. And now we need to construct the general term. So I'm going to do a negative 1 to the n, which means I'm going to be starting with a 1, because that would give me an odd, then an even, odd, even. If this is 1, then this is going to be x to the 2n minus 1, if I want to plug in a 1 to get this, 2 to get this, over the denominator, is going to be 2n factorial. Now, when you're writing these general terms, you could have a different set of n's, if you will. They just have to all match so that they generate this series. Okay, next is going to be x squared cosine of x. So I'm going to start again with my cosine of x. And then multiply everything by x squared. So this will be x squared. This is going to be x to the 4th over 2 factorial. This will be x to the 6th over 4 factorial. X to the 8th over 6 factorial. Our general term here, do a negative 1 to the n to get the alternating. We're going to have x to the 2n over 2n minus 2 factorial, because this is 2 lower than whatever this is up here, plus dot, dot, dot. Okay, for cosine squared, I can't simply just square it. So what we're going to do is actually use the trig identity that says cosine squared x equals 1 plus cosine 2x, the double angle identity. So this will be 1/2 plus 1/2 cosine 2x. Okay, so as a series, we're going to have 1/2 plus 1/2 of the series generated by cosine 2x. So that's going to be 1. We did the 2x on the other sheet, so you can look back. Sorry, this should be 16. And then a minus 64, and this is to the 4th, 64 x to the 6th over 6 factorial. Okay, we'll deal with the general term later. I'm going to distribute through that 1/2, so we're going to have 1/2 plus 1/2, and then I'm just going to take the numerator and divide it by 2. So minus 2x squared over 2 factorial plus 8x to the 4th over 3 factorial minus 32 x to the 6th over 6 factorial so we have 1/2 plus 1/2, so 1 minus 2x squared over 2 factorial plus 8x to the 4th over 3 factorial minus 32 x to the 6th over 6 factorial. So our general term, we have our negative 1 to the n to get the alternating piece. And then here, this is going to be 2x to the 2n over 2n factorial. Okay, here, a1 is x squared, and my common ratio is x. So x squared plus x cubed, 4x to the 5. Okay, so this is going to be x squared times x to the n, or we could do this as x to the 2 plus n if you wanted to. Okay, so we've got our A Maclaurin series is 1 x over 2 factorial, x squared over 3 factorial, x cubed over 4 factorial. So x to the n over n plus 1 factorial. Okay, so f prime is going to come from the coefficient of the linear term. So that's going to be 1/2. For the subsequent ones, we want to look at the pattern here. So let's look at f double prime of 0 over 2 factorial, in this case is going to equal 1 over 3 factorial, which means the second derivative is going to be 2 factorial over 3 factorial, which would just be 1 over 3, since this would be 3 times 2 factorial. Okay, let's do another one, just to see if we can find a pattern. So for the third, okay, the general term is the third derivative of 0 over 3. In this case is supposed to equal 1 over 4 factorial. That means my third derivative is 3 factorial over 4 factorial, which is going to be 1 over 4. Okay, so the second derivative was 1 over 3, the third derivative was 1 over the 4, so I can say that the nth derivative is going to equal 1 over n plus 1. So this is going to be 1 over 11. Okay, so now we're going to multiply this series by x. So that will give me x plus x squared over 2 factorial plus x cubed over, x cubed over 3 factorial plus x to the 4th over 4 factorial. Okay, the general term here would be x to the n plus 1 over n plus 1 factorial if we're starting at 0. Well, if we look at this, it looks kind of like e to the x. The only thing that's not there, e to the x starts with 1 plus x squared over 2 factorial and so on. So g of x is going to equal e minus 1. Okay, for this section here, we want to find the sum of the series. So essentially we're saying what is represented by this thing here. Okay, so recognizing the sigma notation of our major Maclaurin series, this one, x to the 2n, that's the evens. This is cosine of x. So here, it's all the same thing, except for instead of x, we have pi over 3. So this is going to be cosine pi over 3, which is going to equal 1/2. Here I kind of have the same thing, but I've got a 4 to the 2n over 5 to the 2n. So this is going to equal cosine of 4 over 5. This one is the odds, so this is sine of x. This, we're replacing the x with pi over 3, so this is sine of pi over 3, which is root 3 over 2. Here, again, we have the 4/5, so this is sine of 4/5. X to the n is our 1 over 1 minus x. That's just one we want to know. And then we're replacing the negative x, the x here, with a negative x over 3. This is e to the x, which makes this e to the 3. This one is going to be e to the 1/3. Right, so what function is approximated? So this is sort of like sine of x. Sine of x is equal to x, all the odds, x cubed over 3 factorial plus x to the 5th over 5 factorial, and so on. So to get this, if I multiply everything by x squared, I will get that shift that we're looking, because these are 2 higher than that. So this will be x cubed minus x to the 5th over 5 factorial plus x to the 7th over 5 factorial. Sorry, this should be 3. Okay, so my answer here is x squared sine of x. This one, a1 is x over 1 minus x, or you could take the 1 over 1 minus x and multiply it by x, but we get this. All right, so last question here. We've got x to the 4th, x to the 5th, so x to the 4th over 2 factorial, x to the 5th over 3 factorial, x to the 6th over 4 factorial. Okay, it's not alternating, and it has all of the powers rather than just even or just odd. So these ones that involve trig functions are not going to be valid. So it's going to be e to the x. So let's look at the manipulation. E to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Okay. Well, my powers are all 2 higher than their denominator. So I'm going to multiply by x squared, which is going to give me x squared plus x cubed plus x to the 4th over 2 factorial plus x to the 5th over 3 factorial. So we're getting closer. Okay, this is where our series starts. So to get my series, we want to subtract that and that. So my correct answer here is D. And that is our first day of manipulating power series.